Is the screen visible, everyone? Okay. So last class we started about introduction to digital. We discussed first about signal, then we discussed about the analog signal, discrete signal, digital signal. Then we started with binary system, why we are using this. Then we discussed about different number system like binary, octal, hexadecimal, decimal. Then we discussed how to convert any number system into a decimal number system. What is the method for that? What is the shortcut for that? Then we discussed how to convert any number system, how to convert decimal number system to other number system. Means decimal to binary, decimal to octal, decimal to hexadecimal, like that. Then we discussed how to convert binary into octal and hexadecimal. To convert binary into octal, we need to form the group of 3. To convert binary into hexadecimal, we need to form the group of 4 bits. Then we see what is the binary equivalent of 0 to 16. So at least you should remember binary equivalent of 0 to 15. Okay. So we have done up to this much in the last class. So anyone having any doubt up to this? Otherwise, we can proceed to the next part. No one having any doubt up to this?
No, sir.
Okay. So next is binary addition and subtraction. So we know that in binary we are using only two numbers, either it is 0 or 1. So if I'll add this, four possibilities are there. Okay. So if we'll add 0 with 0 in binary, what will be the result? Anyone tell?
0.
No, it is not correct. Anyone else?
1.
1.
1. No, it is also not correct. Again, it is only two possibilities. It can be 0 or 1. So 0 is also not correct, 1 is also not correct. Anything else?
0 1.
0 1. Okay. No, it is also not correct. So last option 1 0 or 1 1 or double 0.
Double 0.
Okay, double 0. Why double 0? Anyone? So like in case, suppose, think about decimal number system. If you add 4 with 4, what will be the result? If you add 4 with 4, what is the result?
8.
Okay, you are saying 8. Okay. Now, suppose you will add 4 with 7, what will be the result?
11.
11.
11. Okay, so you are saying 4 plus 4 is 8, 4 plus 7 is 11. So, what is this and what is this? We are adding two one digits, but here we are getting two digits. Okay. So in decimal also, when you are adding, one is called as sum. When you are adding two numbers, one is called as sum, one is called as carry. Okay. So exactly same thing will happen in case of binary also. Okay. So when we add two numbers, you will not get one output. Remember, this is important. You are not getting one output. You will get two outputs. This sum and carry. So what happens for this case? Sum is also 0, carry is also 0. Is it clear? So we'll add 0 with 0, both sum and carry will be 0. Next, 0 plus 1, what should be the result now? Now it is straightforward.
0 1.
The sum will be how much? Sum will be 1, carry will be 0. If you add 1 with 0, sum will be 1, carry will be 0. Okay. If you add 1 with 1, what will happen?
1 1. 1 carries 1.
Sum is? What will be? Okay, sum is 1. Carry?
Carry also 1.
Okay, let us simplify. We don't know, we are not able to answer. Okay, so you don't know, you are not sure it is right or wrong. So, this one I wrote, this is in binary, this is in binary. Okay, so if I'll add this number, okay, what will be the decimal equivalent of this one? What is the decimal equivalent of this number? It is given in binary. If
One.
I'll write 1, great. So decimal also this will be 1 only. This is also 1 in binary. In decimal also it is equal to 1. So if we'll add 1 1 in decimal, what will be the result?
2.
2.
2. So here, suppose result is x, result should be such a way that it should be equal to 2 in decimal. Okay. So what is 2 in terms of binary?
1 0.
1 0.
1 0. Great, it is 1 0. Now tell what is sum, what is carry? Who will be sum? This will be sum, this will be carry. So what will happen? Sum is 0,
Carry will be
carry will be 1. Okay, is it clear? Now another task. If I'll add 1 with 1 with 1, what will happen? Exactly same way you can find out. If I'll add 1 1 1 in binary, what should be the result?
So firstly the
1
will be
1.
added, then after 0 1 will be added. So
No, whatever internal part you do it. Final result. So whenever you
Sir,
add,
one-
you will
one-
only 1 second. Whenever you add, you will only get two results. One will be sum, one will be carry. Okay. So we are not bothered about what is happening inside. In the end, what we should get. Okay. Again, same method. If we convert this into decimal, one is binary is same as one in decimal. So if we'll add them, what will happen? This is one in decimal, this is one in decimal, this is one in decimal. So if we add them, what will happen? This will be 3. 3 in decimal. What is 3 in terms of binary?
0 1
Sorry.
1.
1 second.
1 1.
This will be 3 will be 1 1. Okay. So sum is also 1, carry is also 1. Okay. So now we understood about this sum and carry. Okay. So now two 4-bit numbers are given. One number is given as 1010, one number is given as 0011. So we need to add this 4-bit numbers. Okay. So what will happen? We'll add 1 with 0. If we add this, what will happen? What is 1 plus 0? This. क्या होगा आंसर? Sum. What will be sum?
1.
So carry will be 0. There are right carry. Carry written here. Next, what you will add? Next, you will add 0 with 1 with 1. So what will happen? 0 plus 1 is 1. 1 plus 1 is what? This one. Sum is 0. Carry is 1. Then 1, we need to add with 0 with 0. So what will happen? Sum will be 1. Carry will be 0. Finally, 0 plus 1 plus 0, sum will be 1. Last case, no need to write the carry. No need to write the carry because carry is equal to 0 only. So if we add these two numbers, what happened? We got result as 1101. 1101. Okay,
Sir, if the last digit has a carry.
Sir, can you tell this once again?
again, okay. Another question someone was asking.
Sir, if the last digit has a carry, then it will be a 5-bit.
Yes, result will be a 5-bit only. That bit will be 0, so no need to write.
Okay, sir.
Okay. So another thing we'll discuss later on, it is that we are not writing in pen and paper. So suppose like you are adding 7 with 6. That means you are adding two 1-digit numbers. Okay. So if we add them, you will get 13. So it is a piece of paper, so I'm able to write here. But in case of this addition, where you will get that? You need to store it somewhere. Okay. It is stored somewhere. So where you will get that place for this? Okay. So in that case, addition is also not be possible. You will get a wrong result if sufficient numbers are not there. Okay. So we'll see that later on. Another one asking some question? Anyone else was asking?
Sir, can you please explain 1 plus 1, 0 with 1 carry?
1 plus 1. This example or what you are asking?
Sir, this example.
Okay. First of all, we'll add here 1 with 0. If we'll add 1 with 0, what I will get? This one. How much will be sum? Sum will be 1. Carry kitna hoga? Carry will be 0. Next, what will happen? We'll add these three numbers. Okay. So 0 plus 1 is 1. Then 1 plus 1. 1 plus 1 is what? This. 1 plus 1 is what? Sum is 0. Carry is 1.
Sir, what is the explanation to 1 plus 1 sum 0 and carry 1?
This one now? 1 second. See here. If we're adding 1 with 1, okay, these two are in the binary numbers. Okay, so we don't know what will be the answer. So what we can do? We can convert them into decimal. What is the decimal equivalent of 1? If it is in same as 1 only, because we understood that this is nothing but 1 into 2 to the power 0 discussed here. Here we discussed how to do that. For this case, this used to be this. So if it is 1, it will be 1 into 2 to the power 0, which is equal to 1 only. So what will happen? This will be 1, this will be 1. Both are decimal. Decimal addition, we know how to add them. So if we
Yes,
add
sir.
1 with 1, this will be 2. So whatever is the result here, that means that has to be 2 in decimal. Okay. So what is the binary equivalent of 2? Binary equivalent of 2 is 1 0. That means what? This sum needs to be 0. This carry needs to be 1. Okay. So that's why here sum coming 0, carry is going as 1. Next 1 plus 0 1. Again 1 plus 0 1. Sum 0. Again this addition is equal to 1. You will get 1 1 0 1. Okay. Next, let us understand the subtraction. Okay. Like here we got sum and carry. What you will get in case of subtraction? Can anyone answer? Like two results here we got. In case of subtraction, what will get? Decimal, what you are getting?
First one 0 0.
No. Two outputs. Again, here also we'll get two output. So what are those two outputs? Huh? Suppose you are making here 33 minus 18. Okay. So how you used to subtract? What you used to do?
Sir, by taking carry from another side.
No. Carry goes to the next digit. What is the problem here? Here first you need to subtract 3 with 8. Okay. So 3 is smaller, 8 is larger. So what will happen? Here you need to take a borrow. If we take a borrow from here, this will become 13. 1 will be minus here. And this will become 2. Then what happens? 13 minus 8 becomes 5. 2 minus 1 becomes 1. So result becomes 15. Okay. So what happens? In case of subtraction, we are getting two output. One is called as this difference. One is called as this borrow. If requirement comes, we used to take the borrow from the next bit or next digit. So exactly same thing happens here. So if I subtract 0 with 0, difference is also 0. Do I need any borrow here? Borrow is not required. So borrow is also 0. Let us skip this for a moment. Next, let us concentrate on this 1 minus 0. 1 second. Hello, Sanam sir. नहीं सर क्लास चल रही है. Okay. Next is 1 minus 0. So here, do I require any borrow here? Is it any borrow required?
No, sir.
Not required because A is larger than 0. So borrow should be 0. 1 minus 0 should be 1. Here also 1 minus 1. Both are equal. Borrow is not required. So difference is also 0. Borrow is also 0. Okay. Next. This one is important. Keep that in mind. Shouldn't used to get confused here. Next is 0 minus 1. First of all, 0 minus 1 means, first of all, you need a borrow. Okay. So what will happen? First of all, what should be the value of borrow? क्या होना चाहिए borrow का value? Borrow should be equal to 1. Okay. Now, like in this example, when 1 comes here, what happens to this 3? This becomes 4 or this becomes 13?
13, sir.
This becomes 13. Okay. So similarly, what will happen here? When 1 will come here, this will become 1 0. This will become 1 0. Okay. 1 will come from the next bit. So when 1 will come, this 1 is nothing but this borrow only. Okay. So when we get a borrow of 1, this will become 1 0. So actually now it becomes 1 0 minus 1. 1 0 minus 1. So what is actually 1 0? What is the decimal equivalent of 1 0?
10.
No, decimal equivalent of 10 नहीं होगा. Decimal equivalent is 2. 1's decimal equivalent is 1. 2 minus 1 is what? 1 only. Okay. So क्या होगा difference? So difference will be also equal to 1. Okay. So keep that in mind. 0 minus 1 is you require a borrow of 1 and difference will be also equal to 1. Difference will be also equal to 1. Is it clear up to this? So is this internal or not remember? Not to remember. Just remember this. Difference will be 1, borrow will be 1. Okay. So let us try then here. What will happen? This example 0 minus 1. I will require a borrow. So from here borrow will come. Borrow will go from here. So if 1 will go there, what will happen? This will become 1 0. So what is this difference here now? Difference is 1. Now when 1 will go from this to this, how much will remain here? Like here. So when 3 out of 3 it goes there, it becomes 3. So now this 1 will become 0. So 0 minus 0 is 0. 1 minus 1 is 0. 1 minus 0 is 1. Okay. Let us check this. Let us verify whatever we got. We got the same result or not? Okay. Let us convert this into decimal. What is 111? What is 1110? 1110 कितना होगा? Same method that we followed in the last class. This is 1, this is 2, this is 4, this is 8. This is 14. This one?
5.
This one is 5. So 14 minus 5 is 9. Now check it here. 8 plus 1, 9. 9. Getting. Okay. So this is the basic of binary addition and binary subtraction. Okay.
So,
Yes.
so can you explain the subtraction one by taking the example of the addition one, sir, that we have taken first one?
Same example we're talking.
Yes, yes, so that addition one you have taken now.
Okay. I understood your point. Okay. So that will become a little bit complicated now. Okay. So what will happen? Okay. Now tell. First, what will happen here?
Sir,
0 minus 1. I will require a borrow here. From here borrow will come. From here borrow will go.
yes, sir.
So this becomes 1 0. Because borrow goes from here, this becomes 0. Okay. So now 1 becomes 1 0 minus 1. So difference is 1. 1. This borrow is 1 and difference is 1. But now we have a problem. What is the problem? Now because of taking borrow from there, what happens? This also becomes 0. Because 1 was there, so this becomes 0. Now 0 minus 1. Okay. For 0 minus 1, I will require borrow. Can I take borrow from this place?
No, sir.
This is already 0. We cannot go further than this. Okay. Then what to do? Let me take it from here. Yes, sir. Okay. So what to do? From here, one second, let me write again. So now situation is this. We got here 1. Okay. Now, what will happen? This first part is already covered. This part is finished. Next, I am looking for 0 minus 1. But I cannot take borrow from here. So what to do? I will take borrow from this. If I take borrow from this, what will happen? This will become 1 0. Okay. So how much will be remaining in that place? Most significant bit.
0.
Zero.
Here, this will become 0. Okay, done. Now, think little bit, then answer. Before answering, think for a while and then answer. Now, from here, I need to take a borrow to this place. Okay, from here, I need to take a borrow to this place. So, what will happen? If I take borrow here, what will happen? This will become 1 0. So, now the question is, how much will be remaining here?
Sir, zero.
Okay, anyone else?
Sir, 1.
For
1.
one,
One.
1.
So we got two answers. One is 0, one is 1. So tell with reason why it will be either 0, why it will be 1.
so it will be one because one
Okay,
zero
one,
is two.
one by one, one by one, one by one. First, let us start with 0. Why it will be 0? Okay, 1 is the correct answer. Okay, let us start. Why 0? Because doubt comes from there only, na? So why it should be 0? Generally, what you are thinking? You are thinking that out of this 1 0, this 1 is going to this. Is it like that?
No, sir.
Then why it will be 0? Generally, it seems like this only. This 1 will go to this place, so 0 is remaining. Otherwise, why it will be 0?
Yes, sir, it looked like that, sir.
It looks like that. Okay, but it is not the case. What happens? To understand this, you can again refer to that decimal subtraction. Okay, you can try for this 1 second. 46, suppose. Okay. इसको 2 कर देते हैं. Okay. How will subtract here? Okay, 1 second. ये भी नहीं होगा. जीरो कर देते हैं. हाँ, अब बताओ. अब कैसे होगा? 206 minus 78. First of all, what should be the answer? What should be the result of this? What should be the result of this subtraction result?
Sir, 128.
128.
128. So we'll verify that we are getting 128 or not. Okay. How is to get that? First of all, 6 minus 8, not possible. Okay. So what is to do? We needed to take a borrow from here. It is already 0 here. So next what to do? Borrow will go from this place. Okay. So if borrow will go from this, what will remain here? क्या यहाँ पे remaining होगा? 1. What will happen here? This will become 10. Okay. The basic point is here it is 10. Here it is not 10. It is 1 0 in binary. Here in decimal it is 10. Out of this 10, borrow will go to this. When borrow will go to this, what will happen? This will become 16.
16 and this will be 9.
Yes, this will become 9. This is the point now. Okay, what happens? Out of 10, how much goes to this? 1 goes to this. So 10 minus 1 is how much? 9.
9.
Okay. So now we can verify 16 minus 8, 8, 9 minus 7, 2, 1 minus 0, 1. Okay. This is the same way we used to subtract. Now, it is exactly same. Only thing is, out of 1 0, we are taking both to the next place. But this 1 0, here I cannot write 9. 9 is not possible in binary. So out of 1 0, what will happen? 1 will go. So to understand this, let us convert this into decimal. What is the decimal equivalent of 1 0? 2. From this, 1 should go. So how much will remain? 1. 1. What is the equivalent of 1 in binary? 1 only.
0 1.
You're taking 1, it has to be 1 only. Okay. So what will happen? Out of 1 0, when we take borrow to the next place, this will become 1. Okay. Now simple. This is 0 minus 1, so this will become 1. 1 minus 0, this is 1. 0 minus 0, this is 0. So how much is result? 7. Let us verify we got same result or not. 1 0 1 0. What is 1 0 1 0's decimal equivalent? 1 0 1 0. Decimal equivalent, how much? This is 1, 2, 4, 8. So how much will be 1, 0? 10.
10, 10.
0, 0, 1, 1, 3. 10 minus 3 is 7. We got exactly the same result. Okay. Is it clear? Binary addition, subtraction.
Yes, sir.
These are the basics. Okay. So we'll be not required that much also, because we will not wanna do this kind of addition subtraction. Okay. Basically we'll deal with addition. We'll change our problem. We'll not do subtraction. Later on we'll see in this class only. So now from this you understood that addition is different, subtraction is different, or they both are same. The process is same or different?
Different.
Both are different. So if I will need a circuit to implement this kind of work which will do addition and subtraction, obviously because this process is different, obviously I will require two different circuits. One circuit which will do the addition, one circuit which will do the subtraction. So for similar kind of work, unnecessarily I will require two hardwares, two circuits. Okay. So to avoid that, what we'll do, we'll convert somehow, we'll see later on, we'll convert somehow this subtraction problem to a addition problem. Okay. So we'll see by doing addition, somehow we'll get the result of subtraction. We'll do in such a way that by using addition only, we'll get the result of subtraction. Okay. In because of that, using only one circuit, we'll be able to achieve both addition and subtraction. So we'll see later on. Let us proceed to next one. So till the time, whatever we discussed about the unsigned numbers. We are not bothered about the sign. Did we discuss about negative sign or positive sign? Till the time we have not gone through the signed numbers. We have not discussed yet about the sign, positive or negative. So whatever we discussed, same thing. If I will represent 3 in binary, what will happen? This will be 1, 1. If I will represent 4 in binary, what will happen? This will be 1, 0, 0. If I will represent 7 in binary, this will be 1, 1. If I will represent 8 in binary, it will be 1, 0, 0. 15, 4, 1. 16, 1, 4, 0. 31, 5 ones. Okay. So the point of this slide is, or the point of I'm writing this is, okay, if I'll use two number of bits, okay, maximum will be what? Maximum is 1, 1 only. Okay. What is the equivalent of that 1, 1 in decimal? What is the equivalent of 1, 1 in decimal?
3.
3.
3.
So it is 3. If I'll use 3 number of bits, what is the largest number? Maximum will be 111. Okay. What is the equivalent, decimal equivalent of 111?
7.
7.
If I'll use 4 number of bits, maximum will be 41. It will be 15. If I'll use 5, it will be 51, and this will be 31. This is about maximum. Okay. What about minimum? In all the case, it will be 0, 0 only. 0, 0 means what? 0. 3 bits mean 000. 000 is also 0. 4 zeros,
All zeros.
is also 0. 5 0, it is also 0. So we understood from here that when I am using two number of bit, I can represent from 0 to 3. When I am able to represent using 3 number of bit, I am able to represent from 0 to 7. Similarly, 4 bit 0 to 15, 5 bit 0 to 31. Similarly, if I will go for 6, 0 to 63. So if I write a generalized expression, what can I write? If I use n number of bit, from what to what I can represent? Obviously, it should start with 0. So 0 to what?
0 to n, 2 power n minus 1.
2 to the power n minus 1. So using n number of bits, I can represent 0 to 2 to the power n minus 1. So suppose question comes, I want to represent 223. Okay, so how many bits will be required? Represent 223. कितने बिट चाहिए होगा? How many bits will be required? Represent 223. कितना होगा? How many will be required?
Sir, 8 bits.
8 bits will be required because if I'll go for 7, this will become
127.
127. Will not be possible. 8, 255. So 223 comes into that. Okay. Another thing. So this is one aspect. Another aspect is, now suppose I want to represent, suppose 11. Okay. Using these binary numbers. What will be 11? How many minimum bits will be required to represent 11?
3.
3 नहीं होगा.
4. 4.
क्या होगा? 7 होगा.
3 to 4. And
4. 4 will be how much? 101.
1011.
Okay. Now suppose question comes, represent this 11 using 8-bit numbers. Then what to do?
Add 4 zeros.
Just we need to add 4 zeros before that. Generally what happens? Additional extra bits are required. Okay, because like we have seen there, okay, so what will happen? It is not a pen and paper, so when we will add, extra space will not be given there. So generally more space are required and more bits were taken for that purpose. So 11 is possible using 4 number of bit, but we are going for 8 number of bit. Suppose that if we'll add, suppose out of 4 bit, so suppose when we'll add two 4-bit number, it is not mandatory that you'll get a 4-bit result only. Result can be a 5-bit also. Okay. If a carry comes in the last place, it will become a 5-bit. Okay. So to solve that issue, more number of bits were taken from the beginning only. Okay. So this is the representation of the unsigned numbers. Okay. So next we need to understand how to represent the signed numbers. That means how to represent positive numbers and negative numbers. So to understand that, first of all we need to understand what is 1's complement and what is 2's complement. Once we understand this, then we'll be able to understand how to represent a plus number and negative number. Okay. So suppose let me take 13. Okay. Tell me how much is 13 in binary? Anyone? 13 in binary? What will be
1101.
1101? Yes, simple. It is not that some magic is there. It is only simple. This is 8, this is 4, this is 2, this is 1. Simply we are representing 13 in terms of addition of this. So 13 is nothing but 8 plus 4 plus 1. That's why 1101. Okay. Now, first is 1's complement. 1's complement of any number, that means the 1's complement of 1101 you can find out by subtracting from all the ones. So if you subtract this 1101 from all the ones, then you will get the result which will be called as the 1's complement. So if you subtract this, what will happen? 1 minus 1 will be how much? 1
So
minus
can you
1?
explain this once more, sir?
0. So whatever the numbers is given, this is given 1101. If I want to find its 1's complement, what I need to do? I need to subtract this from all the ones. So if you subtract this from all the ones, whatever result you will get, that will be called as the 1's complement of 1101. Okay. So to find that, we need to do the subtraction. If you subtract now, what will happen? This 1 minus 1, what will be the result? 0. Borrow is not required, so I am not saying about the borrows. Okay. 1 minus 0, 1. 1 minus 1, 0. And 0. Okay. So for this number, its 1's complement is 0010. Let us take another example. Suppose 21. What is 21? How much is 21? 21 कितना होगा? How much will be 21? 16 plus
16 plus 4 plus
this. 16 plus 4 plus 1.
1.
This is 1, this is 2, this is 4, this is 8, this is 16. So 16 plus 4 plus 1, that's why it is 10101. Now, to get its ones complement, I need to subtract this from all the ones. So if I subtract it, what I will get? 1 minus 1, 0. 1 minus 0, 1. 1 minus 1, 0. 1 minus 0, 1. 1 minus 1, 0. So ones complement of 10101 is how much? 01010. So without doing this mathematics, without subtracting, can I directly write ones complement? Is there any relations between this and this?
Yes.
Any shortcut? Just
Sir,
compare this
just
number.
invert the thing.
Just interchange. Just interchange 1 with 0. This 1 is changed with 0. This 0 is changed with 1. This 1 is changed to 0. This 0 is changed to 1. This 1 is changed to 0. So by interchanging zeros with 1 and ones with 0, you can get the ones complement. Okay. So same example is given. Here it is mentioned, first of all, represent 57 using 8 number of bits. Okay. How many minimum number of bits are required to represent 57?
8.
No, 8 not required. Minimum. I'm asking how many minimum number of bits required. 6 bits are required. 6 bits are sufficient. But question is asked 8 bits, so you have to take 8 bits. Okay. So 57 is what? 1, 2, 4, 8, 16, 32, 64, 128. 57 is what? 32 plus 16 plus 8 plus 1. So that's why it is 00111101. Next, how to find its ones complement? Just we need to interchange. This will become 1, this will become 1, this 3 will become 0, this 2 will become 1, this will become 0. So ones complement of 57 is how much? 11, 000, 110. Okay. So any binary number, if you want to find ones complement, just interchange. Interchange 0 with 1 and 1 with 0. Is it clear? Up to this, is it clear?
Yes, sir. Got it, sir.
Okay. Next. Next is 2's complement. Okay. So to find 2's complement of any binary number, what you need to do? First of all, you need to find the ones complement. After finding ones complement, you need to add 1 with it. If you add 1 with it, it will give you the 2's complement. Okay. So we have already done here. For 13, ones complement is 0010. If I'll add 1 here, what will happen? How much you'll get?
0011.
1 second. 1 is 1 plus 0, 1. All this 1 is 0, 0 only. So 0011. Similarly here, what will happen? 1 second. Here also we need to add 1. If you add 1 here, how much you'll get? 1, 1, 0, 1, 0. This will be the 2's complement of 10101. Okay. Exactly same thing is mentioned here, same example. 57, 1's complement we already got as this much. If you add 1 with it, we'll get this result. Okay. So 2's complement you can be able to find out just by finding 1's complement, then adding it with 1. But again, it is a difficult task. It is really a difficult task. If you first find 1's complement, then if you add, okay. So we'll require some kind of shortcut for this, so that by seeing directly the number, we'll be able to find the 2's complement. First check the number. Here see 2 example. Okay. 2 numbers are given, 104 and 105. First verify, is it correct? 0, 11, 01, 000. Is it same as 104? 104 is how much? 64 plus 32 plus 8. Okay. This is 1, 2, 4, 16, 128. So if you add these numbers, you will get 104. 105, what will happen? Only this 0 will change to 1. This will become 105. Okay. Now, out of these two numbers, what is the difference here between these two numbers? How they differ? Everything
Only
is same.
last one. Yes.
Okay. What is the name of that bit? What is the name of that bit?
Least significant.
Least significant bit. So both of them differs with least significant bit. For the top one, least significant bit is 0. For bottom one, least significant bit is 1. Okay. Let us first do this manually, then we'll go for a shortcut. So, what will be 1's complement of 104? Just interchange zeros with 1, zeros with 1.
1 0 1
So
0.
this will become 1, 00, 10, 111. Then, to find 2's complement, what to do? You need to add 1 with it. If you add 1 with it, what will happen? 1 plus 1, what will be the result?
0.
Sum is 0,
And
carry
carry
is 1. Carry is 1. Now, we need to add 1 with 1 again. 1 with 1 means
0.
sum 0, carry 1. Again, we need to add 1 with 1. Sum 0, carry 1. Then, we'll add 1 with 0, so 1. Then, other part are 0 only, so same thing will be copied. So, how much is result? 1 double 0 double 1 triple 0. Okay. Same way, verify for this 105. Is it correct? Is it correct?
Yes, sir.
Okay. Now, time for the shortcut. Okay. So, what to do? Whenever a number is given, you can directly find the ones complement by interchanging 0 with 1. Okay. So, now what to do? Let us start with this. Let us start with top one. 0, double 1, 0, 1, triple 0. Okay. So, you need to start from least significant bit. You need to start from least significant bit. Whatever is mentioned there, you copy it. What is mentioned there? 0. So, you copy it. Okay. Next. So, this first bit is 0. So, you keep on copying till you encounter the first one. Till you get the first one, up to that time, you just copy it. So here 0, copied. Next also 0, copied. Next 0, copied. Next 1, copied. Now here you are getting the first one. Once you get the first one, then you interchange zeros with 1 and ones with 0. Again I am repeating, you will start from least significant bit, and you will keep on copying till you encounter the first one. Once you get the first one, after that we interchange the bit. That means change 0 into 1 and 1 into 0. So now 0 will be changed to 1, 1 will be changed to 0, 1 will be changed to 0, 0 will be changed to 1. So this will be the 2's complement of that number. Verify. 1 double 0, 1 double 0, double 1, double 1, triple 0, triple 0. Okay. Exactly same example 105. So how it changes? In 105, directly least significant bit is 1. So I will copy that. Already 1 is encountered. Once you get the 1, after that what to do? Everything else will be changed. Everything else will be interchanged. So 0 will become 1, this 0 will become 1, this 1 will become 0, this 0 will become 1, this 1 will become 0, this 1 will become 0, this 0 will become 1. So this will be the 2's complement of that number. Okay. So is it clear? Shortcut, is it clear? How to find 1's complement and 2's complement? Okay. Okay, let us stop here. Next class we'll do this representation. Okay, because we'll not able to finish, so let us not start. So all the representation we'll do in the next class. Okay. So 1 second, let me take the attendance. Don't leave the meeting. Attendance is not taken yet. Okay. Is this screen visible? Yes, sir.
Yes, sir.
101,
Present, sir.
26,
Yes, sir.
58,
Yes, sir.
41,
Present, sir.
1134,
Present, sir.
119, Devi Prasad Naik. Next, 1206,
Present, sir.
1235,
Yes, sir.
1246, 1253,
Present, sir.
1268,
Present, sir.
1315,
Present, sir.
1348,
Present, sir.
1397,
Present, sir.
1399,
Present, sir.
1427, 1427, 1434,
Present, sir.
Sir, 1427 present, sir.
1467,
Present, sir.
148,
Present, sir.
1539,
Present, sir.
1603, Sorodip Sarkar. 165,
Present, sir. 160 present, sir.
165,
Present, sir.
1663,
Present, sir.
673,
Present, sir.
168, Tusar. Tusar. Then 1883,
Present, sir.
885,
Present, sir.
910,
Present, sir.
939,
Present, sir.
985, Bisakha Ghosh. Then 2005,
Present, sir.
205, Harsh Kumar. 207, 2072,
Present, sir.
2110,
Present, sir.
2129,
Present, sir.
213,
7.
213,
Present, sir.
2187,
Present, sir.
2253,
Present, sir.
227, Rohan. 2270, 229,
Present, sir.
2460,
Present, sir.
2516, Pratyus. 2532,
Present, sir.
2540, Sujib. 2680,
Present, sir.
2700,
Present, sir.
2865,
Attending, sir.
2932,
Present, sir.
294,
Present, sir.
318,
Present, sir.
320, Sriti. 3469, 353,
Present, sir.
479,
Present, sir.
491,
Present, sir.
one second later on, 567,
Yes, sir.
575, Sarthak.
Present, sir.
Then 651,
Present, sir.
660,
Present, sir. Present, sir.
678, 798,
Present, sir.
809,
Present, sir.
811,
Present, sir.
814,
Present, sir.
815,
Present, sir.
817,
Present, sir.
825,
Present, sir.
832, 853,
Present, sir.
895,
Present, sir.
936,
Present, sir.
939, Abhijit, 957,
Present, sir.
959, 960,
Present, sir.
992.
Present, sir.
Okay, thank you very much.
Present, sir.
Yes. बोलो.
3, 4, 6, and 3.
3, 3, 4. What you are doing at the time of attendance? Okay, okay.